What's up, Doc? I'm going to do a talk through of the Unit 11 review sheet. This should help you see every kind of problem that Unit 11 goes over. Instead of teaching each individual lesson, then you can have an example of everything. Okay, so with sequences, sequences are things that are changing, and they're either changing by adding and subtracting the whole time, or multiplying by either a whole number or a fraction. So there's a bunch of formulas here. I'm just going to talk about them really quick. Formulas for these are kind of like taking the elevator or the stairs. So the explicit formula, if we are adding and subtracting numbers every time, these are the explicit formulas. If we are multiplying, these are the explicit formulas for multiplying. We call that a geometric sequence, and this is an arithmetic sequence. And explicit formulas are like taking the elevator. You can plug in a number and solve and find the value of the number at that position. So if I'm looking for the 15th number in the sequence, I can plug 15 into the formula, solve it, and figure out what the value of the 15th number is. Same goes for the explicit for geometric. The recursive formula is like taking the stairs. In order to figure out what the next value is, you need to know the previous value. That's that n minus 1 is the previous value, either plus the common difference or times the ratio. And you also need to list the first term that you're starting with. So that's like telling us where the ground floor is, and then you have to take the stairs to get to each floor to figure out what it is. To find the common difference, we're essentially doing the slope formula. And to find the common ratio, we're going to take the square root. The index is the position numbers that we're doing, and then it's the value of that position divided by the other value. We take the square root of that. Partial sum formula is to add up all of the pieces in a sequence, like the first number through the 15th value. What would the total sum of all of those in the sequence be? And then this is the formula for geometric. And then infinite sum. If you have an r that is in between -1 and +1, so that would be anything that is a decimal, not just a decimal or a fraction, but it has to be less than 1 and greater than -1. So like 0.5 or 1/2 or 3/4, anything in between that range, you use the infinite sum because it converges. Okay, so I'm not going to do all of these problems because this will be a very long video and take a long time. But to find the first 5 terms, I'm going to look at numbers 1, 2, 3, and 4 kind of briefly. To find the first 5 terms in the sequence, what we do is we plug in place of n, we can plug in a 1, and then evaluate. So 1 minus 1 is actually 0, and 1/3 to the 0 power is 1 times 4. So the value of our first term is 4. If I need to know the value of my second term, I would do 4 times to the 2 minus 1, because I'm replacing that n with 2. And then I'm going to evaluate. So 2 minus 1 is 1. I'm just going to delete things and rewrite the numbers as they convert. Just for the sake of keeping this clean, you would want to rewrite it, but I don't want this to get too crazy. So 1/3 to the first power is still 1/3 times 4. And so the value of our second term is 4/3. So you just take the number and you plug it in. Okay, so the same thing is true here for like number 2. We would plug 1s in and figure out what our first term is. So 5 minus 6 times 1. 6 times 1 is 6. So this should give us -1 when we add 5 to that. The value of our second term, 5 minus 6 times 2. That would be -12 plus 5. So we get -7. And so that's how we would find we would do that 5 times to find each value. For number 3, this formula is recursive. It's telling us to use the value to find the next value. We're going to use the previous, so I would put 3 here. So to find a of 1 plus 1 is a of 2. So our second term, we're going to plug in the value of our first term and then subtract 3 from that. So my second term is 3 minus 3, which is 0. And then I would use this 0 in the next term to figure out. So I would say, okay, well, to find my third term, I'm going to take the value of my second term minus 3, and the value of my third term is negative 3. So you're taking that and plugging it in. Same goes here for number 4, but you're going to be multiplying. So that is 3 times, like the first term is 5, so the second term would be 3 times 5, and that's 15. And then our third term would be 3 times 15, and that would be the value of our third term is 45. Sorry for my sloppy writing. It's hard to do it clean on the iPad. Okay, to find explicit and recursive formulas, explicit is set up. There's that formula sheet. I'm going to assume that you have access to seeing the formulas, and you can print this out and all those things. So any number term we're looking for is equal to the value of the first term, so A1, plus n minus 1 times the common difference. So the common difference is found by looking at how these are changing. So these are subtracting 3 every time. So D is negative 3. And the first term, we can just look at the sequence. Our first term here is 30. So we were going to say AN equals 30 plus n minus 1 times negative 3. So we can multiply that in and get negative 3n plus 3 plus 30. So any number term we're looking for is negative 3n plus 33. Now we've built an elevator. If I needed to know the 50th term, I would plug 50 in for n and solve. And that would tell me the value of my 50th term. Okay, so that's the explicit. The recursive, we need to list the value of our first term. So our first term is 30. So A1 equals 30. And then I need to say that any term we're looking for is the first is the value of the term that we have before it plus the common difference, in this case minus 3. So if I need to know my second term, I would take my first term and then subtract 3 from that. So this is our recursive formula. In order to figure out the common difference here in number 6, we're going to set up our slope formula. This is like having 3 comma 6 and having 27 comma 54. So it's like having x1, y1, x2, y2. So I'm going to go, I like to set this up with minus signs, and then I stack these. I say 54 over 27 and 6 over 3. And then I would work that out, and that will give me my common difference. So if I do 54 minus 6, I'm going to get 48 over 24, 27 minus 3. And so that tells me my common difference in this pattern is 2. Now that I know that what my common difference is, I can plug that in. I can actually I can use either one of these in my explicit formula. So like any number term I'm looking for is going to be equal to, now I'm using the value of I'm going to use, I'll highlight A3. So I'm going to say is the value that I'm working with plus n minus, and I'm going to say n minus 3 because this is my third term times 2. And so now I'm going to multiply this out. I get 2n minus 6 plus 6. And then when I combine like terms, I find my explicit formula is just any number I'm looking for, I'm going to take 2 and multiply that with the value I'm looking for. Okay? So that's explicit. My recursive, I need to list A1. So I could plug 1s into this formula, right? 2 times 1 is 2. So my first term is 2. And then an minus 1 plus the common difference of 2. So that's how you do those. I'm going to kind of bounce down a little bit further. We do have geometric sequences. So geometric sequences, we're going to say, how are we getting from one thing to the next while we're multiplying 3? So for this, our ratio is negative 3. It's negative because the signs are flip-flopping. We're multiplying negative 3 to everything. Okay? To set up the geometric sequence is really easy for these. It's any number term we're looking for is going to be equal to hold on, let me go back and look at the formula. It's been a while since I've thought about these. That's right. The value of the first term times the common difference. You could say like negative 3 to the n minus 1 power. And that's it for this. So there's our explicit formula. We don't have to like simplify and solve like we did for arithmetic. And then for the recursive, we need to list the value of our first term again. So our first term is 4. So I'm going to say A1 equals 4. And I'm going to say that, okay, I need the value of the term before the one I'm looking for times my common ratio, and that will give me my next term. All right, so now it's time to show you how to find the ratio if you're given 2 like parts from the sequence. And this is from that formula up there. But what we're going to do is we're going to take 8 minus 4 as our index. Okay, so that's like, I know it looks funny. That's inside the square root, just being dramatic with it. And then I'm going to take the value that's further along is going to get divided. Oops. Is going to get divided by the value that's not as far along. Okay, so I'm going to have 243 divide 2 divided by 24. Now this looks crazy, so what I'm going to do is I'm going to just work this out. 243 over 2 divided by 24. That's 24 over 1. So we keep change flip. Let's see, 243. And like, you're going to notice that I did something weird and I don't see what it is right now. Let's see, 243 divide 2 divided by 24. It's just 243 over 48. I'm missing something here. Oh, duh. These are both divisible by 3. Sorry. It's been a while since I've thought about this, and it's weird doing it in real time. And I don't know how to edit things. So if I divide both these by 3, I get 81 over 8. Oh, sorry, no. 48 divided 3 is 16. 16. I was looking at the 24. So I need to find the fourth root, because that's at 8 minus 4, of 81 over 16. And the fourth root of 81 is 3, and the fourth root of 16 is 2. So this is my r. Sorry, that was so clunky. R equals 3 over 2. What's nice is I don't have to go in and find my A1 for my explicit. I can use either of my values and just plug them into the explicit formula where they correspond. So like I could say like any number term I'm looking for is going to be equal to the value I have times r, 3 over 2, to the n minus, and then whatever the position was, so n minus 4. Okay, sorry that one got wild. You can now plug 1 into this and solve, and you'll get the value of your first term, and you can write your explicit formula from that. Okay. So I'm going to go up to, there's a lot going on here. Okay, I'm going to look at the sum formula, and this isn't really meant to be watched in one sitting. Like, watch each piece, watch it a couple times, go try some problems for each kind, okay? This is called the sum formula, and this one's an arithmetic, and that's because I don't have any exponents in this. So this is telling me it's an arithmetic. So this is saying take all the numbers between 1 and 14, positions 1 and 14, and if you were to add all of those together, what would the total be? And this is the thing that's taking place. So there's a couple things here. The sum formula, the sum of all the numbers in an arithmetic sequence is found by taking the number of those that you have divided by 2 times the value of your starting plus the value of your ending. This is our starting, and this is our ending. So I need to plug in and figure out what do I get when I plug 1 in, what do I get when I plug 14 in. So when I plug 1 in, 5 times 1 is 5, minus 1 is 4. So there's the value of my starting. The value of my ending, 5 times 14, is 70, minus 1 is 69. And I guess there's an n here. Now, so we have those two values, but we're missing our n value. And n is not 1. I know n says 1 here, but that means the number of terms that we're working with. And the way that we figure that out is going to be the same for every single one of these. We're going to take the final ending number of 14. We're going to subtract the starting number of 1, and then we're always going to add 1 to that. So it's top minus bottom plus 1. In this case, it ends up being 14. You would solve this, and that will give you your sum. Okay, so same idea here. You're going to plug 33 into this and get a number. You're going to plug 5 into this and get a number. When you do 33, you're going to do 7 times 33 minus 10 and get 221. Or you can do 5 times 7 minus 10 and get 25. And so in your sum formula, it's the number of terms divided by 2, and then the value of your starting, which is 25, plus the value of your ending, 221. And then the way that we find the number of terms is by taking the top minus the bottom plus 1. So 33 minus 5 plus 1. So 33 minus 5 plus 1 is going to give us 29. So when you evaluate that, that'll give you your answer. Okay, let's see. This is an infinite sum, so this is geometric, and this has to do with that bottom formula here. The trick is you have to check your r first. So in this problem, our r is the things being raised to the power, so it's negative 2 over 3, and that is in between negative 1 and positive 1. So this is going to work for the infinite sum formula, which means we take the value of our starting term. That's what that A1 is here. So the value of the starting term, we have to figure out. For geometric, you don't have to plug in the top and the bottom. We only plug in the bottom value. So you would plug in your bottom value for k. Now if k is to the 0 power, that means that whatever it's raising is just going to become a 1. That's multiplying by that 2 that was outside. So that our very starting value here is 2. So in our formula, our infinite sum formula, we have our very starting value over 1 minus r. r is negative 2 over 3. So you would plug this into a calculator, and that would give you your answer. Okay, here's a good geometric sequence. So for this one, you don't plug in top and bottom. You only plug in the bottom because we are, and this is not infinite. So our regular formula here is going to be the value of the first term times 1 minus r to the n divided by 1 minus r. And it's probably a good idea to put this in parentheses in the bottom, because if you forget to use parentheses in your calculator, it throws the answer off. Okay? So that a1 doesn't always mean we have to plug in a 1. It's just our starting term. It's whatever the value is from this. So when I plug n in here, I get 2 times 3 to the 3 minus 2 power. So 3 minus 2 is 1. And 3 to the first power is 3 times 2 is 6. Okay, so I get 6 when I do that. So what's going to go in that orange position is going to be a 6 times 1 minus. Now remember, r is the thing being raised to the power, so it's the 3. 1 minus 3 to the n. Now we need to figure out what our n is. N is top minus bottom plus 1. So 7 plus 1 is 8. So n equals 8 over 1 minus r. There's our 3. If you put this in a calculator, you get your answer. Okay? And some more arithmetic sequence, kind of similar to what we were doing up here. You would create your explicit formula. Based on this information, you could figure out your explicit formula. Sorry, this information. And then you would plug 45 into that explicit formula and figure out what the value of the 45th term is. Okay? And then you have some word problems. The real tricky ones are going to be these percentage ones. If your value is increasing by 10%, your r is not 0.1. Your r is actually 1.1 because you're adding 10% to the original value, which means you have your original value, 100% of your original value, and then the 1% the 10% that's affecting that. Okay, so your r is 1.1. Your stock is a1 is 100, so that's what you're starting with. And then what will be the value of the stock at week 13? This is going to be explicit formula. And just plug 13 in for n for your explicit geometric formula. Okay. Let's see here. Jennifer stacking logs, placing 81 on the bottom, 79, so on. So this is going to be arithmetic because we're changing not by multiplying but by subtracting. So our common difference here, we're subtracting 2 logs every time. There are 40 rows. The number of rows is 40. And we want to know how many logs will she need in total. So for total, that's telling us we need to do our sum formula. So we know the number of rows that we have is 40. We need to figure out the value of the first row and the number of logs in the first row and the number of logs in the last row. So you're going to create an explicit formula based on this, and then you are going to be able to plug in 1. Well, actually, you know what your first row is. It's 81. And then so you would just plug in for your 40th row, and then that's the number that will go here, and then you do your formula. Okay. Let's start savings account. So again, This is increasing by $15. And I forget if this one's explicit or sum formula. And I don't want to make this video too long trying to figure it out. I already got stuck on this dang problem over here. So, you know, try both or try one of them, and then if you check the answer key, if that's right, great. If not, try the other one, learn from it. Same thing goes here. We're depositing, you know, 1 cent, 3 cents, 9 cents. So if this pattern continues, it's multiplying by 3 cents. So you can say times 3 and do your geometric. Let's see, cupcake business on the first day she sells 30, then 34, then 38. So this is changing by adding 4. So this one, your D is 4. How many cupcakes will she sell on the 50th day is just telling you for explicit formula, and then plug in 50. That's different than like how many did she sell in total. That would be adding up all of the cupcakes from each day to tell total. So you don't have to use your sum formula for that one. Okay, so I don't want to make this video too long. So hopefully this was helpful and at least kind of helped you start getting your brain around this. All right, that's all, folks.